In this section, we'll look at some trigonometric integrals, which many times are simply products of two different trig functions. These will actually get used quite a bit in finding the final answers of another technique that we'll use with trigonometric substitution, and then they'll come back again toward the end of the class. We're really just applying U substitution here and just learning techniques of how to set up U substitution to work whenever we have products of trig functions. So for instance, if we have products of powers of sine and cosine. All right, so notice how I've written these. I have sine to the j power of x times cosine x dx. So the idea here is in that form right there, tell you what, let me highlight that one. So in this form right here, if I were going to substitute, then what I would need to do, I'll just come back over here and do this, I will say that u is equal to the function that has the exponent on it. So in this case, that would be sine of x. So that du would be cosine of x times dx. So that when we finish substituting, this problem would look like the integral of u to the j power du. And then that's something that we could apply just a power rule to. Similarly, in the other, we would just be substituting, letting u equal cosine. So essentially what we have is a remaining factor of sine or cosine that we want to preserve and use for substitution. And that's kind of the impetus on how we choose to do what we are going to do here. So what will ultimately happen is we'll have powers on both sine and cosine, but we're not going to be able to integrate with that. What we'll need to be able to do is rewrite some of those powers in such a way that every term is just entirely of sine or cosine, and then there's a remaining factor of either sine and cosine left over for u substitution. So to get these to transform, what we'll use is the Pythagorean identity. So anytime we have a pair of sine functions or cosine functions, we can take that power sine squared and write it as 1 minus cosine squared. So we can transform two factors at a time of one of these functions in terms of the other. And as long as that allows us to isolate just a single factor, so something to the first power, then we would be able to use u substitution. So essentially what we're looking for is like an odd power on either one of these functions, so for sine or cosine. All right, let's take a look at an example in case possibly you're getting a bit lost in my explanation here. So maybe that'll make it a bit more concrete for you. All right, now starting with this first example, what I have is cosine cubed of x times sine of x dx. Now sine is already power 1, which is great. We can use that for the preserved factor with u substitution. So for instance, I can write u is cosine of x, and then du, cosine's derivative is negative, so this will be negative sine x dx, so that this term right here would become u to the third power. Just remember, just in case, cosine, well, I could say cosine to any power of x. This is the same thing as just cosine of x to whatever that power is. So it's just a shorthand notation for writing powers of trig functions. And then this part, sine x dx, is going to get replaced with essentially negative du. So it's not minus du, of course, but factor of negative. So our integral will become negative of the integral of u cubed du, which we can integrate with the power rule, so negative u to the fourth over 4 plus some arbitrary constant, and that would be negative 1/4. Since u was cosine, this would be cosine to the fourth of x plus a constant. And there we have it. We've integrated this particular function. But let's take a look at a little bit more difficult of an example. All right, so next up here I have the integral of cosine squared x times sine cubed dx. Now, in this particular example, what we're going to do is we're going to choose the factor of either trig function that has an odd power. That's essentially what we need, because, like for instance, if I come down here, I could say sine cubed of x could be written as sine squared of x times sine x. All right, and that's exactly what's meant by cube, so that should be no trouble there in understanding. But because of the Pythagorean identity, I can also say that sine squared is 1 minus cosine squared x, and then times sine x. And what that would allow me to do is preserve one factor of sine in order to use for u substitution, and transform all the other factors of sine into cosine so that I can actually do the substitution. So let's walk through the steps here. All right, so I'm going to rewrite this. I have cosine squared x. I'm not changing it for a moment. But sine cubed, I'm replacing with everything down here. I'm going to write it as 1 minus cosine squared x times sine x dx. Okay, now I could almost do u substitution, but I think there's one additional thing I'd like to do first. I'd like to take this factor of cosine squared and distribute it into this set of parentheses. So that's going to give me the integral of cosine squared x minus cosine to the fourth of x times sine x dx. Okay, now I think I can do some u substitution, because if I let u be cosine, so even though I have multiple powers of cosine, that's okay. All of those are going to get absorbed into just the variable u. And then I just have this one factor of sine left over, and that's all I need for u substitution, because du is now going to be negative sine x dx. So this would become, after substituting, negative integral. So cosine squared will turn into u squared minus u to the fourth. And then sine x dx is getting taken care of through the du. And then, of course, I have my negative here. And in fact, I could actually distribute that negative. So if I distribute the negative into the integral, it's going to make each of those terms negative and effectively just turn the order of this binomial around. So u to the fourth minus u squared du. Now we integrate, so this would be u to the fifth over 5 minus u to the third over 3 plus c, and I could just express that finally as, say, 1/5 cosine to the fifth power of x minus 1/3 cosine to the third power of x plus c.